Hi everyone, in this video we are going to discuss hydrocarbons. So hydrocarbons are one of the main components in petroleum, but we'll talk about petroleum in a different video. Right now I want to make sure that when I say the phrase hydrocarbon or the word hydrocarbon, you know exactly what I'm talking about. So let's start off with a very basic definition. A hydrocarbon is just a compound made entirely of, and this is obvious, carbon and hydrogen. But that's it. That's all that's in the compound, okay? So we have three different classifications of a hydrocarbon. We can have an alkane, an alkene, and alkyne. So you must know the definition of these. So let's start off with the first one, an alkane. Alkane, so A-N-E, is telling us that within this hydrocarbon, there are only single bonds. So all of the carbons are singly bonded to each other. So an easy example of that would be ethane. So here is our single bond to a carbon. Carbon always wants to be attached to four different things. It has 4 valence electrons. So you would draw it out like this. So this is ethane. Okay, only single bonds between the carbon. Let's go to our second category. Our second category would be called an alkene, E-N-E. And so this ending is just saying that somewhere within the molecule there is a carbon-carbon double bond. Now, this means that the entire hydrocarbon could be all single bonds, but there is just one double bond somewhere. Okay, it's not all double bonds, it's just indicating that there is at least one double bond in that hydrocarbon. Classic example of this would be ethene. So now carbon wants to be attached to 4 things. So we have 1, 2, 3, and 4, and then it's symmetrical, so it looks the same on this side. So this is ethene. Okay, now our last one is an alkyne, or like an alkene. It's kind of hard to say. It's an alkyne. I kind of think of it as like I-N-E, but it's actually Y-N-E. And so this ending means that there's a triple bond. Okay, so now an example of this would be ethane. So it has a triple bond here, so 1, 2, 3 wants to be connected to 4 things. It would look like this. Now, for this course, I expect you to know what an alkane is, an alkene is, and an alkyne is. So you just need to know that within a hydrocarbon, this word is telling you how many bonds there are between a carbon, if it's a single, double, or a triple bond. So now, specifically, I expect you to memorize a number of alkanes. I will never ask you to memorize alkenes, and I will definitely never ask you to memorize alkynes. So let's go through the ones that I expect you to know, and you must know these. All right, so let's start off with the name. We're also going to talk about the formula. We want to talk about the boiling point. So the boiling point is simply just the temperature at which your substance goes from a liquid to a gas. So the temperature at which it boils. And then the last thing we're going to do is classify the phase. So the thing we need to know most importantly here is that your room temperature is at 25 degrees Celsius. So if something boils at a temperature below 25 degrees Celsius, it's going to be in the gaseous phase at room temperature. If something boils above 25 degrees Celsius, it's going to be in the liquid phase at room temperature. I only expect you to memorize the name and formula. From the formula, you already know how to go from the formula to the structure. So I expect you to know name, formula, and structure, but I'm not going to draw out structures here because you already know how to do that. So let's go through the 8 I expect you to know. First things first, let's start simple. Methane. Methane has 1 carbon. It has a formula of CH4. It has a boiling point of negative 164 degrees Celsius. It's below 25, so that means this must be a gas at room temperature. Next one is going to be ethane. Ethane, saying we have 2 carbons, and then we have 6 hydrogens. This has a boiling point of negative 89 degrees Celsius. Also below 25, definitely a gas. Let's go to the next one. The next one is going to be propane. Pro saying that we have 3 carbons. Now let me show you the trick. When we're trying to determine how many hydrogens you're going to have for an alkane, these are only alkanes, you double this number, so 6 times 2, and then you add 2. So 3 times 2 gives you 6. You add 2, so that's 8 right there. So that's how you determine how many hydrogens. This would be negative 42 degrees Celsius. Also below 25 would be a gas. Next one, butane. Butane has 4 carbons, so 4 times 2 is 8, plus 2 gives us a value of 10. So our boiling point is negative 0.5 degrees Celsius, so almost at 0 degrees Celsius, also a gas. So now the first 4 are gases, and the next one is a big jump, so we move to pentane. Pentane, meaning that we have 5 carbons. 5 times 2 is 10, plus 2 gives us a value of 12. This has a boiling point of 36 degrees. Now, this boiling point is above 25 degrees Celsius. So at 25 degrees, pentane is definitely in the liquid phase. Moving on. Hexane. Most of the time you're going to hear this pronounced as hexanes with an S at the end, but for our course, hexane is fine. So C6, 6 times 2 is 12, plus 2 is 14. This has a boiling point of 69 degrees Celsius, definitely a liquid. Okay, you will smell hexanes a lot in nail polish remover or any type of nail polish. Heptane is next. This is C7, and then we have times 2, so 7 times 2 is 14, plus 2 gives us 16. This has a boiling point of 98 degrees Celsius. This is definitely a liquid. All right, last one you have to know is octane. Oct, saying that we have 8 carbons, C8, and then we multiply it times 2, plus 2 gives us 18. This definitely has a boiling point of 125 degrees Celsius. So this takes a lot of energy to get it from the liquid phase to the gaseous phase. All right, quick question. Make sure we all understand this. How many single bonds, and I mean total in the entire molecule, how many single bonds are in, and we're going to pick heptane. So like I said before, I fully expect that you can take that formula and give me a structure. That was old material. You've done this before. You need to know how to do this. How many single bonds? Go. All right, did we get an answer? Hopefully we did. Let's draw it out just in case you weren't there yet. So Hept says we have 7 carbons. So 1, 2, 3, 4, 5, 6, 7. Ane means that they all have single bonds between them. There's no double bond, no triple bond. Now remember, carbon wants to be attached to 4 things. So we're going to start with the one on the left. It has 1, 2, 3, 4. Perfect. Now this carbon, 1, 2, it just needs 2 hydrogens, 3 and 4. And then all of these in the middle are going to look the exact same. So in my mind, when I'm doing this and drawing out my really big chains for my hydrocarbons, I feel like I'm drawing out a centipede, which I'm not, but I like that. Okay, and then the end again, I have to have 4. So 1, 2, 3, and 4. This is your structure for heptane. So now I asked for total single bonds, so we're literally just counting. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. 22 single bonds in heptane. Bye, guys.